All right, and so du would be 1 over x dx, and the v, what's the antiderivative? Well, what, it'd just be x, right? I mean, it's 1, basically the dv is 1 dx, so the antiderivative of 1 would just be x, right? And so you would have that. And so now, according to integration by parts, this would be x ln x minus the integral of v du. Now, I think some of you, when I've seen people struggling with integration by parts, a lot of times when you do this last piece, the v du, it can simplify. And people are just writing down v du and then not understanding the simplify. I think you're better off just, before you write it down, simplify. Go off to the side, somewhere, and just do it. Or in this case, it's easy in your head. What's 1 over x times x? Just 1. Just 1 dx. Because I think sometimes if you write x, 1 over x dx, and you look at that, what do I do with that? You don't, the thought of simplifying doesn't occur to you. I think you should simplify it before you even write it down. Well, that's easy. What's the antiderivative of 1? X, and then plus c. So it's x ln x. Notice we don't need bars around it because we were given ln x originally. So we know x is positive in this problem. Has to be. So we're not concerned with it. And then minus x, and then plus c. And some people might say, well, I just rather memorize that, whatever. But that's how you would do with the antiderivative of natural log, is you would just do that. We also said, well, let's do one more. Let's do arctangent. We said there's not, that was one of those on that page. It just had arctangent, might have had a 5 inside of it or something, right? But you wouldn't have to really worry about that, but, right? So let's say we had this. Well, we have no antiderivative for arctangent. Right? We have a derivative of arctangent, but we have no antiderivative of arctangent. Well, this one we could use integration by parts. Again, inverse trig is early in the Liate thing. That's something we want to use for u. So we would let u equal arctan x. And the dv would just be what's left, which is just the dx. Right? And so we do our du, which is 1 over 1 plus x squared dx. And our v would be just x. So according to arctangent, according to integration by parts formula, it's u times v. So that's x arctangent x minus the integral of v du. Now let's look at that. Is there anything that simplify, or how would you write v times du? How would you write that? Put the x on top. X over 1 plus x squared dx. Right? Now, is that an integral we can do? Not just simply, but we can do it. How would you do it? We would let u be the bottom. The reason you'd want to let u be the bottom is because 1 plus x squared, your du would be 2x dx. There is an x dx setting right up there, right? So it's just going through this is just good to just review these processes anyway. Process of integration by parts, process of u substitution. So the du is 2x dx. We're going to move that 2 over there. In u substitution, we do that. Remember, we move that 2 around. We would never do that in an integration by parts over here, right? We don't move stuff around. We just plug it into the formula. Okay, so now this new integral here would be, well, the x dx. That would be a 1/2 and a du. 1 over u, so that's ln. So this would be, so the whole answer here would be x arctan x minus, and then this would be 1/2 ln, and what was u here? 1 plus x squared. That's never negative, so I don't have to worry about my bars, but I could put them, and then plus c. Now, I don't think that's something you want to memorize, but what this what these three little problems show us is that some of our basic functions, if we go back to our derivative list, we had rules for everything: sine, cosine, tangent, secant, cosecant, cotangent. We had rules for everything. Arctan, arcsine, natural log, e to the x. We had rules for all of them. Well, some of those functions don't have simple antiderivatives, and what this little exercise is showing, but we could get them. Right? Tangent, we write it sine with cosine, do a u substitution. We can get its antiderivative. Natural log, we don't have an easy one that we memorize, but we can use integration by parts to get it. Okay? So integration by parts doesn't really have to have two parts. I guess if you count the dx as a part, it does. We let u be that and dv be what's left, which in this case is just the dx. So that can happen, and the same thing for our tangent. Integration by parts can get it for us. Okay, that's the antiderivative of our tangent. Not very nice. And so that's why we don't put it on the list to memorize. We'll just find it if we need it. Okay. Now, what used to happen in the old days, back up a minute. It's kind of like when you first learn how to add and subtract, multiply, divide. Your teachers don't let you use calculator, right? You got to memorize that stuff. You got to work with it. You gain some number sense and that kind of thing. And then as you move into algebra, now you get to start using your calculators more. And you don't have to do long division much anymore and stuff like that. You just do it. Grab a calculator and do it. Okay. Now, in the old days, before calculators, we had slide rules and stuff like that. Well, I'm not that old. I came along just after slide rules, and the calculators were being used. The only difference is a calculator like this, what didn't look like this, it was bigger, and it was about $80. But, so I got to use those. I got to use a calculator. But when I was in school, the back of the book always had a bunch of tables. The back of the book always had tables. It had square root tables. So if you needed the square root of 47, you went to the table and you looked at 47 and you went across the square root and had it out to about 5 decimal places or something, because before the calculators you used to look those things up a lot. Okay? Well, think about what we've done in calculus. We did the gateway test with derivatives, didn't get to use our calculators a lot, but then when we got into the applications and the story problems in chapter 4, we got to use our calculators a lot for those derivatives. We didn't take the time to calculate a lot of those things. But we wanted to have the sense of what a derivative was, and sometimes just easier with that. Same thing is true here. These antiderivatives, every time we want the antiderivative of our tangent, we're going to go to it? No. But what we used to do is we had tables. You had books of tables of integrals. Matter of fact, the back of our books, now these have been rebound so many times that a lot of you don't have it anymore, but if you turn to the back of your book, now I've got one of my original ones, I've got the back cover has got a table of integrals. Now I'm not sure if yours has been rebound, you may have lost that page. But if you've got one of the blue ones, okay, you may have that. But if you go to your back, but you may not. Because when they rebind it, they take off some pages and they don't have anything in it. So, or you might have just one page of the table of integrals. You might have lost this one. Which is not a big deal because we don't use it much anymore, but that's what we used to do. If we had to do a complicated integral antiderivative that we didn't know what it was, we would look it up in the table. Now this particular table has 64 entries. You guys have taken chemistry. Did Mrs. Larson show you the CRC handbook? You talk about the CRC handbook with all the formulas and all that stuff in there. Well, in that CRC handbook, there's also a table of integrals. Depending which version you have, there's 700 and some. There's a table of integrals that's 700 and some different integrals in it, where you would have to look up. You would look these up in a table of integrals. Well, that's what our calculator is now. Our calculator is like an electronic table of integrals, right? They're all in there. They're programmed in. So if we really need to do an antiderivative with arctangent or something, we'll be doing that. So later on, we'll be doing a lot of this just with the calculator, after we've gotten through it and went through and learned it and gained a sense of how these things work and how this operates. All right. So anyway, so you don't have to memorize those things, but if you had to do an antiderivative like this, okay, integration by parts, right? Think about on the gateway test, they're either going to be basic ones that you've memorized, like power rule and those kind of things. They're going to be u substitution. Well, you look at something like this and there's no u substitution there. There's nothing you could put in with that. Or there's going to be integration by parts. Okay? And integration by parts is a small part of it. If you're doing it 10 times on the gateway test, you're doing something really wrong. Okay? Probably no more than 2. All right, what do you want to go over? I've got some review problems I'm going to throw up there like we did yesterday and let you work, and then we'll check them. But maybe starting with this, are there any on here that you want to talk about? No, I know the answers were there, but you still may be confused about something that was on there, so let's talk about it. Anybody have anything on those 11 problems?
On number 4, the like you had to split it, and then with the 9 over x to the third.
Right?
Maybe I'm looking for it. Oh, I copied it down wrong. Never mind. That's
Okay.
correct.
Because it'd be this, and then raise that up to a negative 2. It'd be negative 9 halves x to the negative 2. And on this one, you'd have to kick out a 1/8, right? And here you have an arctangent with a 3 in front of it, right? 3 arctangent. Okay. What else? Here's an integration by parts, right? You got an algebra and you got an ln, right? You got an algebra and an ln, so that'd be I'd let u be the ln, the Liate kind of a thing. Integration by parts.
On number 4, can you kick out a 1/3 and do
Now, but it wouldn't be a 1/3. You'd pull out a 3. Right, yeah, absolutely. Now, yeah, the only disadvantage of that is I think you bring it back in at the end, or you wouldn't have to actually. I suppose you could leave it out there. You could pull the 3 out, then do your antiderivatives and have your final answer be 3 and then parentheses, which I'm fine with. But if you distribute it, the danger is you'd forget about it. You know, the danger is you pull out the 3 and then you do your antiderivatives and you forget about it and you write your final answer. It's not in there. And you know, and again, same thing on the last derivative test. If you're going to get the first one, if you're going to get 8 out of 10, you have to earn it. I mean, it's got to be mistake free. I mean, well, except for 2 of them, right? You can get 8 out of 10, but if you pull out a 3 and then you write your antiderivative, circle your answer, and you know 3's not in there, you left it off, you forgot about it. You know, that would count against you. But yeah, no, that would work. That would work. Okay, good. What else? Here again, it's just a matter of simplifying the set number 7. You can distribute that through there first. I would strongly encourage that. Distribute that through. What about 8 here? Actually, 8 and 9 had a couple of interesting little things that I threw in there. What about 8? What were you saying, Noah? Yeah, I mean, absolutely. This is one that could, you know, you could look at all day long and oh, geez, what do I do? What do I do? And it's really just this over x, which makes it 5x cubed, and then 1 over x, which is, you know, 1 over x, right? And then, so now it's to the 4th, so it's 5/4 x to the 4th, and then plus ln x, right? And then you put in your 1 and your e. So it's just algebra, right? Just split it apart and then go. Now, you're going to have e's in there. So you put an e in here, you have e to the 4th. So that's just in your answer, right? Your answer would just be 5/4 e to the 4th plus ln e, of course, is just 1. And then minus, and then don't forget parentheses here. And you put a 1 in here, and this would be 5/4. And then plus, well, it turns out ln1 is just 0, so that really is not mattering. And then 5/4, and you should simplify that here. So that'd be 1 minus 5/4, that'd be a minus 1/4, you know, something like that. You could take out a 1/4, but there's no need to factor, usually factor if we're going to cancel. And there's not going to be any of that happening. So we just leave it like that. Okay, what about 9 then? What was the deal on 9? Did what?
I didn't.
Well, I think if you go down here, but that one doesn't look like, that one is just a little different as far as the integration by parts, isn't it? Because it's ln x over x squared. But we could bring that x negative 2 up, and now it does look more like an integration by parts. Okay, so again, so it's a Liate. So it is an integration by parts, but it didn't quite look like one. With division, Normally, our integration by parts wasn't division, but that one we could turn to a multiplication real easily. But what if that would have been, here was my thinking here, and because I think we've had this one before. What if, let me just change that a tiny bit. What if that would have been that right there? Then it's U substitution. What's the U? And we almost never let U be the top, right? Almost never let U be the top. But our overriding idea on U substitution is whatever you pick for U, you want the du to be setting there. And in this case, if you let U be natural log of x, then the du is 1 over x dx, which is setting right there. The other example of that we had like a sine of, I think it was this the other day. We had this, maybe it was on this packet. We had this right here, right? Well, we let u be the inside. I guess we usually, so that's not a big deal. We didn't let u be the whole top. We just let u be the inside, x to 1/2, because the du is 1/2 x to the negative 1/2, which is right there. That negative 1/2 is down there. I think we did that on the same packet. But anyway, so here you would just have, this would just be the integral of u. This part would just be u, and the rest of this would be the d. So that's 1/2 u squared plus c, which would just be 1/2 natural log. So again, just some little things that can happen. Okay, this was an interesting one. It had a 1 plus 4x squared. Should make you think of arctangent, but arctangent's got to be 1 plus u squared, right, or x squared. Well, just write the 4x squared as 2x quantity squared and do a u substitution. Let u be the 2x. And then you turn it into an arctangent. Okay? Turn it into an arctangent. All right. Anything out of the book or, anything else that you tried? Let me see it. What's that?
It was x times ln x over e to the x.
Of x over e to the x?
Tell me.
No. That's a simplification that's kind of tricky. Anybody see what we can do with that first as far as a simplification? What can you do with a log? What can you do with a log with a division on the inside? Subtract the individual log. So what you can do there is you can do this as ln x minus ln e to the x. Right? So then this would be x ln x minus, and what's ln e to the x? That's just x. So you distribute this x through here. X times x is just x squared. Then you would split that into 2. Now I've talked about doing some simplification, but I'm probably not going to do that to you. Guys, I've said that a lot. I'm not going to make you do that. I'm not going to make you do that. I'm being really easy. But okay, now what would you do though? What would you do with this? X ln x. Integration by parts, right? That's what we do. Algebra to log, right? And there's no obvious u substitution. It's not what we do. Integration by parts. That's an integration by parts, and that's just a simple power, right? But, and we've talked about how there are going to be ones where you've got to simplify them first, right? You might have to do some splitting apart. That's the one we've done the most of with some algebra, that kind of thing. But here would have been a case of doing that. Now, when we get to the final, when we get to some of the packets and whatever, could there be some of this, because then they expect you to do a little more with that log and be able to simplify logs and exponentials and stuff. So that could certainly be something that you might run into. But that would be one where you just simplify it and rearrange it first. Okay? Good. What else? Anything?
There's one in the packet that was kind of goofy, just because it was like big numbers. It was number 50. It's like between 50 and 40. It's like 90,000.
50 on the bottom.
50 on the top.
Okay. So from 40 to 50,
Yeah.
and it was what?
90,000 over 400 plus 3.
Where in the world was that one?
It's like page 341, 50 or something.
3, 4. Oh, yeah. Okay. That was.
Maybe I said it up wrong.
No, you didn't. Number 50, was that? That was just one you grabbed. Was that one I had down?
I think it was on the
Oh, okay. Well, it's a go. It says the demand equation for a product. Remember we talked about business examples. We talked about price equations. The number of units times the price per unit, and the price per unit changes depending on how many you sell and stuff, and what the demand is, that kind of thing. And so what they give you is they give you this little equation P for the price, and it's 90,000 over 400 plus 3x. That's the price equation. Now, what they wanted was what's the average price on the interval 40 to 50? X is from 40 to 50. Well, that's that formula we have, the average value of a function. So what they want is the average value of the price function. Well, we know that the average value formula is the integral of that function from A to B divided by B minus A. Right? So for between 40 and 50 units, they want to know what is the average price. That is something that could be used. Now that gets more into our chapter 7 kind of stuff, which is when we get into our applications and uses. Chapter 7 is kind of the chapter 4 equivalent we had on derivatives. When we did all those different uses for derivatives, we'll be getting into the different uses of integrals and what they can tell us in kind of some story problem kind of situation. Well, we would do this. Now, you're right, it's got all these numbers, but the real key is this down here, right? So what would we do to solve this one? It's really a U substitution, and to be honest, it's an ln. It's just an ln with a 1/3 kicked out is all it's going to be, right? I mean, and you might even be able to just see that. But if you didn't, you would say, well, I'll just let U be the bottom. All those constants really don't matter much because what's the du then? Just 3 dx, we're going to move the 3 over there. We have 1/3 du equals dx. And so our new integral, the 90,000, I could just bring out in front. And so that's just a 1 there then. So, and then this would just be u, right? Now there is going to be a 1/3 out there, right? So that would go out there. And then the du, and then so that's already out front. This is the u, and the dx is the 1/3 in the du. So there it is. So 90,000 divided by 3 is 30,000. ln and the u is 400 plus 3x. And then it's going to go from 40 to 50. Okay, so we put a 50 in there. 3 times 50 is 150 plus 400 would be 550. So it would be 30,000. ln, what did I say that is? 550 minus 30,000 ln, put a 40 in there, what's that, 520? And then all that is over 10, right? And now the gateway test is no calculator, so you wouldn't do anything beyond that right there. Stop right there, or whatever. Take out 30,000, but that's just going to be a number. Now, to be honest, when we get into chapter 7, that's when we'll get to use our calculator. So in chapter 7, when we get to here, we'll just type that. Okay. the whole point of well, think about what chapter 4 was. The hard part of chapter 4 was setting up the equation, setting up the problem. In our story problems with integrals, the hard part will be setting up the integrals. But I got good news for you. It's a lot easier than chapter 4. Remember that story problem test on chapter 4, setting up the max, mins, and all that stuff? Getting those equations set up? Believe me, the integrals we have to set up in our applications are much better, much easier to set up. No problem. Okay? I'm not just trying to keep you guys in class fourth term either. It's true. I'm not lying. All right. Let's take a look at this new set of problems I got here. I got some review problems here. We'll spend some time working on. Okay? Now, how many do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8. 8. Got 8. All right. There you go. Let's work on these two right here. Give these a try. Now, these might be ones, now we might want to try these on our own a little more, right? Not saying you can't talk to each other and compare a little bit, but, you know, now we're getting a little closer. We're a day away, one school day away from the gateway test. We might want to get to the point where we can now see how we can do on our own.